Okay, so in today's class we will start with some converters. Okay, so like converters basically we are first thing we are going to work on buck converter. Okay, so after buck converter we will work on boost converter. Okay, so after that buck boost converters, all these converters are called as DC-DC converters. Okay, there are multiple converters like DC to AC converters, AC to DC converters. Okay, here on the first side we are working with DC to DC converters. Okay, inside that there are multiple converters called like buck converter, boost converter. Okay, buck boost converters. Okay, so let us discuss the first topic, that is buck converter. Okay, yes, so I will share PPT based on the buck converter. So all of you open your laptops, be ready with the MATLAB software. Okay. Yes. So in this PPT we are going to learn about buck converter, and after that boost, then buck boost. So basically the buck means like for the general explanation you can call it as step down converter. Okay, so buck means it will step down the voltage, so it will step down, it will reduce the input voltage, and at the output side you will get the less voltage compared to the input side. Okay, then there is a boost. You can call it as step up converter. Okay, so where it will increase the input voltage, and at the output there will be a like more voltage compared to input side. And at the last one, buck boost converters, where you can do both operations in the single circuit, that is called as buck boost converters. Okay, generally these you will get in the like hardwares, you will get a hardware converter circuits, so you can buy it from online or shop or anywhere. Okay, so these are used in like DC circuits mainly. These are DC-DC converters, so these converters are used in mostly DC circuits. Okay, and in that circuit there can be any voltage, so DC voltage can be 12 volts, 30 volts, okay, 100 volts, anything, but it should only used in the DC circuits. Okay, so after this let us see like simple comparison between these three converters. Okay, yes, so here there is a three converters. Yes, so when it comes to the DC-DC converters, so these are like switching power supply circuits. Okay, like you will convert the signals by switching the circuits. Okay, using MOSFET, transistors, BJT, like that devices, you will switch the circuits. Okay, so after this switching, you will convert one DC voltage level to another level. Okay, so this can be, you can convert 12 volts supply to 24 volts using the boost converter. Okay, you can convert 12 volts supply to like 6 volts or 9 volts using the buck converter. Okay, and using buck boost converter you can do both the operations in a single circuit. Okay, either you can select it for the like step down operations, or you can select it for the step up operations. Both operations can be done in the buck boost converters. Okay, like these are like used in like laptops, solar systems, electric vehicles, and also in the embedded systems. Okay, where you need like multiple voltage variations. So different devices consumes like voltage, different voltages. So for that variations you need to use the converters, where the large voltage is converted into like a very small voltage. Okay, so here we are using only DC-DC converters, not AC to DC or DC to AC converters. These are the DC to DC converters. Okay, yes, so first we will go through the buck converters. Okay, so here you can see there is a formula, so that is V out is equal to D into V in. Okay, so D means duty cycles. Okay, here D means duty cycles into V in. V in means input voltage. So output is equal to duty how much will the duty cycle is given into input voltage. That is a formula. Okay. So here the first main operation of the buck converter is to step down the voltage. Okay. So here if you step down the output voltage means then the output voltage will be lesser than input voltage. Okay. So that's why it is called as buck converters. And you can also call it as step down converters. Okay. And here duty cycle D controls the output. So whatever the duty cycle you will give, that much voltage will be reduced. Okay. So let us say the input voltage is 12 volts. Okay. So duty cycle is 5, then it will reduce half of it. Okay, 12 volts it will reduce it to 6 volts, like that. Okay, if you make the duty cycle to let us say 5, okay, then it will again decrease to 3 volts, like that. Okay, that will be done in the buck converters. Then here the efficiency will be like 95%. Okay, efficiency will be 95%. And common use will be used in the battery chargers. Okay, battery chargers. So chargers always output with a large voltage and large current. So for reducing that power, we will use these buck converters. Okay. And when it comes to the boost converters, here also V out is equal to V in divided by 1 minus D. D means duty cycles. Okay. Yes, so this is a formula for boost converters. So where you can find the here we are increasing the output voltage. That's why the formula is V out is equal to V in divided by 1 minus D. Okay, if you increase the duty cycle means the output voltage will be reduced. Okay, if you decrease the duty cycle means the output voltage will be increasing, like that. Yes, so here what happens, the output voltage will be greater than input voltage. So since it is a step up converter, here the output voltage will be more than input voltage, which is the reverse of the buck converters. Okay, this is a boost converter, and it is also called as step up converters. Okay, so higher duty cycles is equal to higher output. If you increase the duty cycle means the output voltage will be increasing. Okay, and here the efficiency will be up to 92%. Okay, 92% efficiency. Then here the applications are like solar MPPT, LED drivers. So in all types of solar panels we use these boost converters. Why means solar panel basically works based on the sunlight. Okay, so throughout the day there will be the sunlight will be not constant. Okay, now it will be varying according to the timings, while in the morning, afternoon, evening, like that there will be lot of changes in the sun light. Okay, so the solar will generate the voltage corresponding to the sunlight. Okay, so if the sunlight is varying regularly, the output voltage will also vary. Okay, when there is a low sunlight means it will generate very low voltage. To step up that voltage, we will use boost converters in the solar panels. Okay, so that is of buck converters and the boost converters. So then there is a buck boost converters, so where you will use both the operations. Okay, either you can make the circuit as boost converters, or else you can make the circuit as buck converters. Okay, here both the operations, step up and step down voltage, can be done. Okay, and here the output is inverted. Okay, so output is inverted is nothing but like it is flipped compared to buck or boost converters. Okay, or you can also say it as negative. Okay, and here it is the most versatile of the three. So here if it is operating with two operations, so that's why it is more versatile. Okay, it will be not the output voltage will be not constant, so it will be versatile. Okay, and here the efficiency is up to 90%. It is low compared to buck and boost converters. And then here the common use is UPS, battery managements. Okay, there when there is a requirement of high voltage, it will work as boost converter. When there is requirement of very low voltage, then it acts as a buck converters. Okay, there we will use these buck boost converters. So this is all about the introduction of buck converters, converters and buck boost converters. Okay, so after this we will start with buck converters. Okay, so here is the explanation about the buck converters. So here there will be a switch, okay, which opens closes the circuits. Okay, so what it do means it so when the switch is closed, okay, when the switch is closed, current flows through the inductor, charges the capacitor, supplies the load. Okay, inductor stores energy. So here when the switch is closed means when the circuit is closed, then the current flows through the inductor, okay, and then charges the capacitor. So then the current from the capacitor will be supplied to the load. Okay, so after this inductor stores the energy. So this makes the buck conversion of the input voltage. Then there is one more condition, that is switch off. When switch is open, inductor releases stored energy, maintaining current flow through the diode to the load. Okay, so when the switch is off means inductor releases the stored energy. So when the switch is on means inductor stores energy. When switch is off means the inductor releases the stored energy. Okay, and it maintains the current flow through the diode. Okay, so diode, it allows only signals to pass through in a single direction. Okay, that's why it is flow in one direction to the load sections. Okay, so here the equation. So already we have seen the equation. So V out is equal to D into V in. D means duty cycles. Okay, and here the ripple current, there will be a ripple current. So you can calculate the ripple current using this formula: V in minus V out, voltage, input voltage minus output voltage into duty cycle divided by L into F. Okay, inductance into frequency or whatever. Then the condition here is there is a one condition. So V out is always less than V in, because these are buck converters. Okay, always the output voltage will be less than input voltage. So if the output voltage is greater than V in means it is not a buck converter, it is a boost converter. Okay, keep it in mind. So this is our basic information about the buck converters. Okay, so after that here you can see what are all the operations I have explained. Here there is a block diagram. Okay, so this is a DC voltage source. So after this DC voltage source there is a MOSFET switch. Okay, so here it acts as a switch. Okay, when it is closed means inductor will charge. When it opens means inductor will act as a release of current. Okay, which supplies the load. Okay, like this. And here there is a capacitor. Okay, so after capacitor there is a load. Here you can get the output. You can add scope or display or anything. You can add across the load, and you can check the output voltage. Okay, so for the switch there is a PWM generator. So you should give the pulse width modulation signals for the MOSFET switch. To turn on, turn off the switch, you need to give the PWM signals. Okay, so this is a block diagram of buck converters. Okay, yes. So these are the specifications of the buck converters. So initially the input voltage, so this is an example. Okay, consider the input voltage as 12 volts. So here the output voltage is 5 volts. So it is step down. Step down is the buck converters. Then the duty cycle is 0.417. So here we have given duty cycle of 0.417, and then the frequency we have set it for 50 kilohertz, inductance 100 microhertz. Okay, and capacitance 220 microfarads, and resistance 10 ohms, and the output power will be 2.5 watts. Okay, so when you calculate the voltage into current, you will get the power. So these are the steps you need to do in the Simulink. Okay, so I will show it in the live building the blocks and connecting the resistor, capacitor to the circuits. Okay, buck converters. You will get the basic circuits in the online, so you can just check it out. Okay, buck converters. So this is the output side. So we will obtain the graph at the output side. Okay, so when you compare the input voltage graph and output voltage graph, there will be a difference. Okay, where the input voltage will be high and the output voltage will be low. That's why it is called as buck converters. Okay. Yes. So like let us complete the buck converters in the MATLAB Simulink. After that, you can work on the buck converters, boost converters. Okay. Yes. The Open the MATLAB software. Okay. So after this, go to the Simulink library. You will get this library file. Okay. So here you can just click on this icon. You will get the new model. Go to the new model here. Okay. So here we got the library file. Okay. So we are starting with the first circuit, that is buck converters. Okay. So yes, you can pin the library file. Just click on this pin button. Okay. So it will pin here. Okay. Whatever the window you open or close, it will stay here only. So we are starting with buck converter. Okay. Yes. So here we need components like resistor, capacitor, inductor, okay, output devices, all the things. You can take it from the Simulink library. Okay. First thing, we need a scope for the output waveform. So go to the sinks. Take the scope block. So you can just right click and click on add block here. Okay. So we got the scope block. So one by one we will add to the model. So after that you can make the connections. So after this you can take display also. So to display input voltage and output voltage. Okay, scope and display. Then go to the Simscape. So Simscape, go to the Simscape. Okay. So here go to the foundation library. Okay, go to the electrical. Okay, here select the electrical elements. Okay, you will find multiple components related to the electricals. Okay, so here you need to take the there are capacitor, inductors, okay, diodes, all the things. So you need to take diodes. Okay.
And then again what?
Yes. So here go to the Simscape. So here specialized technologies, fundamental blocks. So here go to the elements. Yes, so here we need to take the series RLC branch. Okay, series RLC branch. So when you click like this, okay, right click, we got the series RLC branch. So like that you need to take multiple blocks. So after this we need a diode. So for that go to the electrical, yes, okay, so or else you can directly search here, search for diode. Yes, so here we need to take the diode, this one, okay. Take this diode, right click on add block, okay. So we got the block here. So after this you need DC voltage source, search for DC voltage source. Yes, we got the DC voltage source like this. It will be like this. Right click on add block. So we got the DC voltage here. And after this search for voltage measurement. Okay, to measure the voltage you need a voltage measurement. This one, voltage measurement. Just search for the block and click on add block to your model, okay. So after this you need IGBT for the switch. IGBT, search for IGBT, okay, and take this one, IGBT. So click here, add block to the model. Yes. So after this we need a power GUI block. So for that search for power GUI, okay. We got the power GUI block here. So this one you need to add and keep it in this model, okay. Like if you not taken this block means it will not execute the circuit, okay. Always when you are using the electronic devices you need to use these power GUIs, okay. So without this we cannot run the model, okay. So after this we need a signal, that is a pulse generator. We need to give the pulse signals. So for this for that go to the sources. So here you will get the pulse generator, this one. Right click on add block, okay. So these are the components we require for this to build the buck converters, okay. So all these components you will get in the Simulink library, you can take from it, okay. So let us start the connections. So these are the components, okay. So I will minimize this window, and here the input power supply. So this one, keep it like this, okay. So after input power input voltage there will be a switch, okay. Take the IGBT block, place it here. So after IGBT you need to connect the diode, okay. Keep the diode here and rotate the diode. So you need to connect one end to the top side, one end to the bottom side. So that's why rotate this by selecting it and click on right click of the mouse. Yes, so here it is like the options will come. So go to the rotate and flip. Here click on like counterclockwise, okay. You need to rotate it in counterclockwise like this. The diode direction should be in upwards, okay. So after this, connect the power supply to the diode. So just you can click here and connect it like this. So this is a diode connection. So after diode connection, connect the IGBT switch to the diode. So after one end of the switch will be connected to the input power supply. Okay, so this one is a collector, emitter, and here gate. Okay, so these are the components we required for the like build the input side. Okay, so after this, take the series RLC branch. So you rotate this also. So just right click, go to the rotate and flip, click on clockwise. Okay, so after rotating this, double click. So after this, here there is a RLC option. So go to the RLC and select it as R. So you should take only resistor. So select it R, click on OK. Okay, so now it becomes the resistance. Okay, resistance, keep it here. Okay, so then you need a voltage measurement block. So here we got the voltage measurement block. Connect the resistor to the circuit like this, another end like this, and here the voltage should be measured across the load. Okay, so this is a load, so you should connect the voltage measurement block across the load. So after this, connect this negative to the another end of the load. Okay, like this. Yes. Okay, so after this, here you can connect the display module. Okay, so you can connect display, or else you can connect the scope or whatever. So you can connect both also. You can connect it to the output side. So it will give us like graph output. It will give the display output like that. Okay. So after this, you need to connect the pulse generator. Okay. So before that, give the input voltage as 10. Okay, give the input voltage as 10. Just double click on the DC voltage source. There is a 100 in default, make it as 10. Okay, so and click on OK. So we are giving voltage 10. Okay, for the input voltage. So these are buck converters. So then we need to connect the pulse generator. Take the pulse generator, connect it to the gate. Okay, here there is a IGBT gate pin. Connect it like this. Okay, so then double click on the pulse generator. So here you will get multiple options. So here you need to change the pulse width. Okay, so pulse width will be scroll down. So here there is a pulse width. Okay, so in default there will be a 5. Make it as 50. Okay, so pulse width I will make it as 50. So after this, here there is a period. So change it the value 10. So here in the buck converters, we are taking the value as here by default the period value will be 10 seconds. Okay, you can take whatever the parameter is, but here we are going to take the value as 1 by 2000. Okay, 1 divided by 2000. Okay, so after this, just click on OK. Okay, so we have done with the all the parameters. So after this, just change the simulation time. Okay, so there will be a default, there will be a 10. Okay, so you can change it to any value. So this makes the simulation run for 10 seconds. Okay, so you can run it for any seconds. So you can set it for 1 second, 2 seconds. First we'll check it for 1 second. So after that you can try it for multiple timings. Okay, so and resistance value there will be 1. So by default, so keep it as it is. Okay, so after completing this, just double click on the power GUI block here, power GUI block. Okay, so here there will be it will showing continuous here settings. Okay, just change it to the discrete. Okay, so discrete and click on OK. Okay, So after this you can run the model. Okay, you will get the output voltage. So here we have given the 10 voltage as 10. So here it will reduce the input voltage. Okay, so we will see what is the output voltage. Okay, just click on the run option. So wait for some 5 to 10 seconds. It will execute. Then you can check the output signals. Okay. Yes, here we got the output voltage, so it is still like running. Wait for some time. Okay, so double click on the scope block. Yes, we got the waveform here. Okay, so this is the waveform. Yes, so you can just enlarge it. So here we got the voltage to the 9. Okay, so here the square waves. So this is a DC voltage. So one more thing, you need to add the inductor to the circuits. Okay, so after that it will reduce. So we have not added inductor to the circuit, so just add the inductor. So how to add it means, just copy this block, right click here. Okay, so you can click on copy. Okay, and click on right click here, click on paste. Okay, we'll get one more like component. So just double click this one and make the R as L. Okay, make R as L and give the value as 0.003. 0.003, this is the inductor value. Okay, give the inductor value as 0.003. so after this, connect it to the circuits. Okay, click on OK. So you need to rotate this block, okay, to the horizontal. So click right click on rotate and flip, click on clockwise. Okay, so now we have rotated this component horizontal. Connect it we need to remove these connections. We need to add the inductor here. Okay, so there is one more component, that is the capacitor. That one we need to add after this one. Okay, so connect it like this to the circuit. Okay, yes, so this is the connection. So we have added the inductor to the circuit. Okay, so after this, again we will try to run this model and we will check the output. Okay, so yes, now you can see the output is nothing but like near to the 3.9 or something. So when you double click on the scope means it will be like this. Okay, so there are more variations like this. Okay, so this is also DC signal. Okay, so here the input voltage we have given it as a 10. So here the output voltage it is showing like 4 point something else. Okay, so after this, we need to connect the one more component, that is capacitor. So for that you need to like copy this component and right click, okay, sorry, double click on this, select this as C, okay, C means capacitor, okay, make it as capacitor and give the value as 1 e raised to minus 6, so it will be default, okay, leave it as it is, or else you need to give the value as 0.003, so as same as inductor, okay. So connect it like this here, okay, connect it like this, connect the one end to the upside, another one end to the bottom side, okay. So this is a capacitor connection with the buck converters. So after all these connections, now like we will try to execute this one, okay, and here the output side we have given the voltage measurement, so this one you can also connect it in the input side also, okay, and to check the input voltage, okay. Yes, so this is all about the circuit. So let us add this voltage measurement block in the input side also. We will measure the input voltage. So positive connected for the positive, negative connected to the negative, okay, and add the scope here. So we will connect both the signals in a same scope. That's why double click on this scope, go to the settings. Yes, here the number of axes, make it as 2, click on OK. Yes, we got the 2 graphs here, okay. So first one we will connect it for the output side or the input side. So second one we will connect it to the second plot, so which is output, okay. First graph it will be connected to the inputs, okay, input side. Yes, so this is the circuit connection. So also you can add the like input voltage, you can display input voltage also. Just keep the display here, copy the display and connect the display module to the voltage input voltage sensors, okay, like this. So now when you click on the run option, it will show both output voltage and input voltage. So here the input voltage is 10, the output voltage is 3.933, okay. Also you can change the capacitor value here. So here before it is 1 e raised to minus 6, so just change it to 0.003, okay. So click on OK and again run the simulation. Okay, so like this you can change the voltages. So this is a buck converter, okay. So here there is a input voltage, this is a input voltage, so you can name it as V in, okay. So this one is V out, okay. So yes, don't get confused. Yes, so this is a capacitor, okay. You can name it as C. This one is L, okay. This one is R, that is L means load, okay. Okay, you can name it as R, okay. Already we have given the name as L, okay. So R, inductor. So here we will measure the output voltage, so you can make it as V out. Here this is a V in, just double click on the block name and you can name it as V in, V out, whatever you will. Okay, so yes. So already there is a name called Vin. Okay, you don't know, so it will not save the same name. You need to change something else. Okay, so here you can just give the input voltage like name. Okay, input voltage. This is a circuit for buck converters. Okay. So this is a calculator. So always you need to use the Power GUI block whenever you are building the Simulink blocks or else sim power blocks. Okay. So here we have used the components inside, like which are inside the specialized technology. Okay. That's why we need to use the Power GUI. Without Power GUI, it will give error. Okay. So this is a EV in input voltage, V out. Okay. And here there is a scope. Just double click on the scope, you will give I will show both the graphs. Okay, just you need to click on this auto scale. Okay, click on auto scale, we will get the exact voltage here. So this is here we have given the DC voltage 10. Okay, so these are DC voltage 10. So here we are getting some voltage around 4 volts to 4.41 volts, like that. Okay, so there will be a small voltage variation. So this is called as noise. Okay, it will not get us like a clear or filtered DC supply. You will get some variations in the output voltage. So it is negligible. Okay, so here you can negligible the output voltage. There is a small variations like 4.09 to 4.1 voltage. This is a DC voltage. Okay. So here the input voltage is 10 volts, output voltage is 4 volts. Okay, that's why it is called as buck converters. Okay, this is a buck converters. So you can just select this circuit and go to the settings here at the bottom side, and you can select the create area. Okay, when you click on create area, it will create some area, so where all the blocks will be included in a single box. Okay, like this you can make edits, so which are like more easy to identify the circuits and all. Okay, it will look neatly, and there will be no complex connections between the devices. Okay, so here I have given the values capacitor. So sorry, this one is a sorry, this one is L, I think. Okay, so this one is C, this one is L, sorry. Okay, so inductor value 0.003, so inductor value 0.03. so you need to select. If you need resistor means you can select R. If you need inductance means you can select L. You can if you need capacitor means you can select C. All are available. So here we have selected the inductor. So here we need to select the capacitor. Okay, so here you need to select the R value will be 1. So you can change the value to 10 or anything. So change the values like this. Just click on the run options and check the output voltage. What is the output voltage and all. Okay, so now the output voltage is 4.101. so just check the scope. So here we will get the exact input voltage and output voltage graph. This one is a input, this one is a output. Okay, so for that you can name like this. So this is the output voltage, so you can name it as V out. Okay, so here you can give the line name as V in. So both names will be displayed in the slope. Okay, so here we got the V in graph, here we got the V out graph. Okay, like this. This is the input voltage, this is the output voltage. Since it is a buck converter, so 10 volts is converted to the 4 volts. Okay, duty cycle we will give it in the pulse generator. Okay, whatever the value we are giving in the here pulse width, so this will change the output voltage. So if you vary this value means output voltage will vary. Okay, based on the pulse duty cycles we will change this output voltage. Also this one period seconds. Okay, so if you change this, the output voltage will be varied. So you can set it for 6 volts, 8 volts, okay, 2 volts, 3 volts, like that you can change it to any voltage. So now we have completed the buck converters, okay. So and also we have obtained some multiple values at the output side, at the input side, okay. So we can build the buck converters using the MATLAB Simulink library. Yes. Okay. So if you have any doubts in the buck converter, you can ask, or else we will move to the next concept. Okay, that is boost converters. Okay, so no doubts. Yes, so the next concept is boost converters. Yes, so here also we will use the same type of components, but here the some connection is different, where we will connect the switch and all in like a different place, okay. Capacitor, inductors in a different place. So I will show the circuits when you are when you are making the Simulink model, okay. So here also same method, so but here we are increasing the output voltage, not decreasing. Here we are increasing the output voltage. So you can see the parameters. So input voltage, let us consider the 5 volts. So output voltage will be 12 volts. It is increased, okay. And here the duty cycle we have given 0.583, okay. And switching frequency we have given 50 kilohertz, okay. And inductance value 120 micro henry. Capacitance 470 microfarads. Loads resistance 20 ohm. Output power 7.2 watts, okay. So these are the specifications we are going to give it in the boost converters. Yes, okay. So this is the output graph. So you will obtain these type of graphs in the output side. So here the input voltage is 5 volts. We will convert it to 5 volts to the 12 volts, okay. Output voltage will be greater than the input voltage. Yes, so we will try the same circuit in the MATLAB Simulink library, okay. So open the new model. So go to the MATLAB. So first, before that, save this file, okay. Click on the save. Where you need to save this file means in the desktop folder, where you have created MATLAB Simulink folder in the desktop. Go to the desktop. So here we have created MATLAB Simulink files. Double click on that. So this is a buck converter. So buck converter, name it as buck converter and click on enter. Yes, we have saved the file in the desktop folder. Yes, okay. So now we'll start with the boost converter. Go to the files, or else you can just directly click here. It will create the new model, okay, empty model. So just take a empty model. So here we need components similar to the buck converters, okay. So directly we can search it in the Simulink library, or else you can just go to the certain like settings. Then you can take the blocks. Both are available, okay. So here also first thing we need to take is yes, we'll just list all the components, okay. First one we'll take it as power GUI. Take the power GUI, place it here, okay. Then we need a display module. For the display module you will get directly it in the sources, okay. Sources, sinks. Go to the sinks, take the display module, okay, and take the scope block, okay. So after this you need voltage measurement blocks, okay. Same components, voltage measure, okay. Click on enter. So you will get the voltage measurement block. You will get it will show two voltage sensors. You should take this one, okay. okay, voltage measurement block. So after this you need a diode. Search for diode. Okay, so diode also, there we will get multiple diodes. Okay, you need to select this one. There should be a box, inside that there should be a diode, and there should be a M pin. M means measurement pin. Okay, so take this block, diode. Okay, so then we need a series RLC branch. Okay, series RLC branch. Series RLC branch, take this component. So after this we need a DC voltage source. DC voltage source here. So here also there are multiple DC voltage sources, so you should take this one. So it should be lines, one positive, one negative. Okay, like this. This is the DC voltage source component. Okay, so after this you need to take the IGBT diode. Search for IGBT. Okay, you will find this IGBT diode here. Okay, take this block, place it here. Okay, so these are the components we require for this circuit. Okay, so after this place the DC voltage source on the left side. Okay, and then we need to connect the inductor. So take this series RLC branch, just double click, select the RLC, change the RLC to the L. Okay, select, make it as L, and give the value of 0.003. okay, 0.003. So after this we'll connect the diode like this. So here there is a small changes in the connections compared to the buck converter. Okay, so after this take the IGBT block, rotate it. Okay, so rotate it so that the gate pin should be in the upside. Okay, upside means it should rotate in clockwise. Right click, go to the rotate and flip, click on clockwise. Okay, we got the gate in the upside collector. So connect the collector pin to the yes, so end of the inductors negative pin. So then connect the emitter pin to the negative of the power supply. Okay, so after this take the RLC branch. Okay, make it as capacitor. Okay, double click on that, make it as capacitor, and give the value as 0.006. okay, make it as capacitor 0.006. click on OK. Okay, so you should rotate it in a vertical. For that you can just go to the right click, click on the right button, and go to the rotate and flip, then clockwise. Okay, connect this to the cathode of the diode, and one end of the diode should be connected to the emitter like this. Okay, connect like this. Again copy this block, you should select it for resistor value. Okay, so double click on this, make it as R means resistor. Okay, so now connect the resistor to the capacitor, across the capacitor. Okay, so after this connect the voltage measurement at the output side. So this is a load. Okay, so across load always you should connect the voltage measurement block. Connect positive to the positive here, and negative to the negative of the load here. Okay, and connect the scope block like this. Connect the display to the output side. Also you can connect it for the input also. So just you can connect the voltage measurement block at the input side. Okay, here connect the positive like this, connect the negative like this, and you can give it to the scope here at the output side, directly to this scope. Double click on this scope, go to the settings, and change the number of axis to the 2. Click on OK, close it. So here we got 2 inputs for the scope. Just enlarge it. Connect the input voltage source to the So here we need to connect the output side for the second plot, this one second, and this one to the first plot. First plot is input voltage, second plot is output voltage. Okay, sorry, yes. So after this, double click on the power GUI block. So here there it is showing continuous. Okay, continuous. You need to change it to the discrete. Okay, so after selecting the discrete, just click on OK. Okay, so these are the settings you need to do here. Okay, so like this is a circuit for the boost converter. Okay, here you will step up the voltage, input voltage. So output voltage will be greater than input voltage. Okay, so at the input side we will give the voltage as 10. You can give anything. So we will give the same voltage compared to the buck converter. So we will give the value as 10. At the input there should be a voltage 10. Okay, so after this we need one more block, that is a pulse generator. So pulse generator, go to the signal routings, sources. So go to the sources. So here you will get the pulse generator. Add the block to your model. So you should connect it to the gate. Okay, connect it to the gate of the IGBT or switch. Double click on the pulse generator. So here you need to change the period and also pulse width. Okay, so yes, so by default the amplitude will be 1, period will be 10, so pulse width will be 5 in default. So here you need to change the period to 1 divided by 2000. Okay, 1 divided by 2000. Okay, so after this change the pulse width to the 50 value. Okay, done. So after this click on OK. Okay, we have connected all the devices and also we have changed all the parameters and values. Okay, so now you can run the program and you can check the outputs. Okay, yes, so just click on the run option here, or simulation stop time you can make it as 1 or you can leave it as it is. Okay, so now I will click on the run option. Yes, so here like our program is executed. You can see the output voltage is around 19.43, but input side we have given only 10 voltage. Okay, so this is a step up of the voltage. And if you need to change the output voltage means just go to the pulse generator and in the pulse width just change it to 25. Okay, so let us change this and click on the run option. So now you can see the voltage is around reduced to the 13. Okay, like this you can change the pulse width and you can control the output voltage. Okay, whatever the requirement is. Okay, so let us consider the input voltage is input voltage is 5 volts. Okay, 5 volts. I need to increase the 5 volts to the 9 volts. Okay, so let us check it. What is the value I will get? Yes, we got 6.3 something. So I will increase this pulse width here. Okay, so I at the output side I need 9 volts. Okay, so just go to the pulse generator and change the pulse width. So you increase little bit, 25. I will make it as 30. Okay, so now let us see the output voltage. Yes, so now there is small changes, so we will increase some more, 30, we will make it as 45. Then click on the run option. Yes, now we got the output voltage 9, near to the 9 voltage. Okay, so like this you can control the output voltage by varying the pulse signal. Okay, so this is a boost converter. So before this we have done the buck converter. This is a boost converter. Yes. Okay. So this is also similar. You can change any input voltage and the output voltage. Let us see in the scope block. Yes, so here you can see there the input voltage is 5 volts and the output voltage is 9.3 to 9 volts, like that. Okay, so there is a variations. So this is not a pure DC, you can call it as pulsating DC voltage. Okay, like this. So 9 volts here, this is output. So just you can double click on this, we can name it as V in, double click on this line, name it as V out. Yes, so now you can see it in the graph. V out, this is a V out, this is a V in. Okay. You can change any voltage to the like whatever your requirement is. Okay, so let us check one more example. So I will change the input voltage to the let us say 12. So I need to increment the 12 volts to the 24 volts. So input there is 12, I will set it to the 12. Okay, so let us see what the voltage, output voltage will be. So when you run it, so the output voltage will be near to 23, okay, 23, 22 around it. So I need 24, but it is near to 24. Okay, the 23.48 is nearer to the 24. Okay, so it can like if you increase this pulse signal means it will increase more. Here the input voltage is 12, here we are getting the output voltage as 23. It is step up. Okay, when it comes to the buck converters, so here the input voltage is 10 volts and the output we are getting 4 volts. So here also you can change the pulse generator value. Here pulse width, you can change the pulse width and you can change the output voltage. Okay, yes, so this is all about the buck converter, and also this is the boost converters. So here also you can yes, okay, so here also you can select certain area and you can make it as a single box. Select this space. Here at the bottom side there will be option. Okay, so it shows like create systems, enable like all settings. You should click on create area. Okay, when you click on create area, it will create an area around your model. Okay, so you can name the components whatever the requirement is. So this one I will name it as L. Okay, so capital L, that is inductor. So this one you can name it as C, that is capacitor. This one is R means resistor value. Okay, so yes, here we got the output voltage, so that is V out. So here we are displaying the output input voltage. Okay, so here we can mention it as the input voltage. So here also you can put on display here, and you can name it as V in. So this is the input voltage, you can name it as V in. Okay, so when you run this model means it will show the value. Yes, so here this is the input voltage, that is a 12, output voltage is 23, 24, like that. This is the boost converters. This one is buck converter. Okay, so after these two simulations, we have one more circuit called buck boost converters, which acts like both. Okay, which works as buck and boost, both converters in a single circuits. Okay, how to do the buck boost converters means, so that is also a same simple method. There you need to use some different components, and circuit will be different compared to the buck converter and boost converter. Okay, but the connections will be like similar to that buck and boost converters. Okay, there will be a little bit change difference. Okay. So now I will explain about the buck boost converters, and I will give the give it as assignment. Okay, so you should do it yourself. Buck boost converters. Okay, I have shown buck converter and boost converter. Try it. So if you if you are not able to do the model, means tomorrow class I will do the buck boost converters. Okay. Yes. So I will explain the buck boost converters. So now you understood about the buck converter. After that, we have understood the boost converters. Okay. So here we are working with buck boost converters. So see here, when the switch is on, okay, switch is closed, the inductor is connected directly across the input voltage. Okay. This stores the energy. Inductors stores the energy when the switch is closed. Okay. After that, diode is reverse biased. Okay. If the diode is reverse biased, means capacitor alone supplies the load. When the switch is on, load will be supplied by the capacitor. Okay. Inductor will charge. Okay. Inductor will charge and stores the energy. Okay. And when the switch is off, if you open the switch, means the inductor reverses the polarity. Okay, forward biases the diode. Diode gets forward biased when the switch is off. Okay, and energy flows to the capacitor. So energy flows to the capacitor and load with inverted polarity. Okay, positive and negative will be interchanged, and this when the switch is off. Okay, and here the equation is output voltage is equal to minus D. D is nothing but duty cycle, divided by 1 minus duty cycle into input voltage. These are calculations, so you can find the output voltage based on the input voltage and the duty cycle. Okay, what is the output voltage? You can find it using duty cycle and input voltage. Okay, so here the step down voltage. Okay, you can the duty cycle is 0.5, means it acts like buck converter. Okay, buck mode. If the duty cycle is greater than 0.5, means it acts as a boost converter. Okay, like simple. Based on the duty cycle, it will act as buck, or else it will act as boost converter. Okay, at a time it will not act buck boost both. Here you need to change the duty cycle. Based on that duty cycle, it will work. Either it can be buck converter, okay, or else it can be boost converter. There is two options in the converter, same circuit. Okay, so take an example. Here we are giving the 12 volts. Okay, so for the 12 volts input voltage, the output voltage we are getting 8 volts. 8 volts is nothing but it is reducing the input voltage. That means it is a buck converter. Okay, when the duty cycle is 0.4, means it acts as a step down converter, and again the duty cycle, if you change it to the 0.6, okay, that is greater than 0.5, then it acts as a step up. So where the 12 volts is converted to the 18 volts. Okay, here there are two options here, so I will show you. Yes, so input voltage is 12 volts. If you make the duty cycle as 0.4, means the output voltage will be 8 volts, and if you change the duty cycle to 0.6, means it will act as step up, and the same 12 volts will be converted to the 18 volts. Okay, and here the switching frequency will be 50 kilohertz. Inductance value will be 150 microhenry. Capacitance will be 330 microfarads. Okay, and the load resistor will be 15 ohms. So these are the rating values you should give in the Simulink model. Okay, so after this, here there is a output signal. Okay, when the duty cycle is 0.4, the voltage is 8 volts, which is step down. Duty cycle is 0.6, means the output voltage is 18 volts, then it becomes step up. polarity will be inverted, so negative output, so you'll get minus 20, minus 30 like that output voltage. And here the efficiency will be around 80 to 88 to 90% efficiency, okay, because here there is more switch and also diode losses, okay. Diode is forward biased, reverse biased, there you will get some losses of the power, okay. So here there is a convert comparison summary, okay, between buck and boost converter, okay. So here let us check output versus input. So in the buck converter, there will be output voltage will be lesser than input voltage, okay. When it comes to the boost, means it is reverse operation of the buck converter. Then the buck boost will be either buck or boost, both operations will be done in the buck boost converter. And polarity will be same in the buck converter. We got the positive value in the output side. Boost also we got the positive value, but in the buck boost we will get the negative value, okay. Then there is a formula for the buck converter is duty cycle into input voltage. Boost converter input voltage divided by 1 minus duty cycle, okay. So here is the buck boost converter formula. Then switch position, so series, it will be series with respect to the input voltage, okay. And here in the boost, shunt to the ground, okay, parallel to the ground. And here buck boost series with respect to the input voltage, okay. And the diode position, so here freewheeling, so diode is freewheeling, and in the boost it is a series, and buck boost it will be in a series, okay. Efficiency you can see it here only 94, 91 and 88%, okay. So when it comes to the complexity, buck converter is simple and simple connections with very low components, okay. And when it comes to the boost converter, it will be like medium, so compared to the buck converter it will be more complex, okay, and connections wise and also parameters wise. And buck boost will be very high compared to buck boost converter, it is more complex, okay. Applications, as we already discussed, buck converters is mainly used in the battery chargers, boost converters are used in the solar panels, and buck boost converters are used in the UPS AVs, okay. Simple, think of when there is a lot of load variations, there will be a buck boost converters, okay, to increase if there is a requirement to more power, means it will act as boost converter. If there is a requirement of very low power, means it will act as a buck converter. That's all, okay. Yes, so this is all about the buck converter and boost converters. So if you